Hi guys, welcome to Learn Electronics Repair. We have another DEA K-15A amplifier. This is from a full range active speaker. I fixed two of these a little while ago. I actually had the third one here at the time, but the customer asked me to go on to other repairs, so this got left on one side. And now I'm back to have a look at it. The other ones I don't have here anymore. The customer had those back. They were working fine. I was paid for those repairs. Let's see if we can get this one to work. So the fault on the other two was basically the same. And that was these resistors here were getting very hot. They power a 24 volt supply down here. There's a Zener diode. So the power comes down a cable running along here, ends up down here on a 3-pin connector, but there's only 2 wires attached to it. That's tucked under here, under this glue. Okay. We have a resistor here, which I think was a 51 ohm. And we have a Zener diode, which I think actually was that one. Okay. And the Zener diodes were short on the ones I had, and the resistors were burnt up. And I suspect the problem was caused by this glue, which you see has gone hard, dark. This tends to go conductive. Okay. To clean all this off, I had to remove the boards from the amplifier, which is a bit of a pain in the butt because this has a lot of transistors all along this edge. You can see down here, transistor, transistor, transistor. They go all the way along that edge. And you have to unsolder them because they are bolted to the heatsink underneath. Down there, and you can't get at them to unbolt them. But fortunately, if you remove the power supply board, that's this one, then these are like large holes where the legs go through, so they're quite easy to unsolder once that's taken off, and you can basically get at it. Now this one didn't have the same fault as the other two. It has the same symptoms as the other two, but doesn't have the same fault. We can just double check, but I'm pretty sure this diode is not short circuit on this one. In fact, it reads 0.702, which is exactly right for a Zener diode, so it's not short on this one. The resistor, let's just check it, is 50 ohms or 51 ohms. Something like that. Oh, but that reads high. So maybe this one actually doesn't have a short here, but the resistor may be gone anyway. Let's have a look. Yeah, definitely reading high. So I suspect then that this one also has the 24 volt supply missing. Okay, so let's power this up. It says blue on, which I think means the blue light comes on. Let's see. The blue light does come on. It's not in protect mode, there's no signal, but we didn't hear the relay click. Yeah, there's no click of the relay, the protection relay. Switch it off. Eventually it goes off again. Let's check the voltage rails. So 84 plus. Let's try to get down here. 84 minus. 50 plus. 50 minus. Yeah, I know the colours are not the way you expect them. And then the Zener diode is not referenced to the same ground, okay? You quite often find this in amplifier circuits where the supply for the protection circuit isn't referenced to the same ground as the amplifier. There must be a good reason for that. So what we need to do is just find a suitable ground we can measure this. I could just measure directly across the Zener. Actually, that might be the easiest way, to be honest. So let's go at it. So switch it on again. This should be a 24 volt supply. And we only have a very low voltage there, okay? 0.17 of a volt. In that case, because I know these things fairly well now, I need to check the voltage here on these resistors, okay? I think I can use the same point on the anode of the Zener diode as a ground reference. Let's have a look. So once again, power it up. What do we have here? 50 volts. They're in parallel, by the way, the two resistors. So we have 50 volts here and we have no volts there. So that pretty much does suggest that the problem with this one is the resistor that's open circuit. Yeah. So I'm going to have to get this board off here like I did with the previous ones and then get down to this part of the circuit and let's have a look. I will just make sure the capacitors have discharged before I dismantle this. Yeah, that's pretty much gone, as has that one. Just check on this 50 volts, has that gone? No, there's 47 volts there because that's another thing it tells us. There's no load on that supply, that's why it's still there, okay? Let's just check these ones as well, see if these have discharged on this supply. Yeah, 0.8 for a volt. Minus about 7 volts, it's not a lot in that now. This one again, 44 volts. Oh, you can reference it there. I honestly thought it was referenced elsewhere. Okay, so what we can do is just discharge this with a capacitor discharger. And here is the one that I built. So ground, end of these resistors. Well, if I have a good connection, that is gone, yeah, discharge. Let's just double check. Yep, it's now gone. So I take this apart. Because I never trust myself to remember properly, that's just a little diagram, shows you which one goes where. Of course, these days you can just take a photo on the mobile phone, but I guess I'm a bit old school and that does the job. This is the funny connector I mentioned, by the way, on that drawing. So these are the two wires which come down from that 50 volt supply, which gives the 24 volt supply. And there's a 3-pin socket on the PCB and a 2-pin plug that goes in it. And this is that glue I was saying about. So this glue becomes conductive. That is a problem, okay? We need to get that off the board. I also suspect from the other ones I repaired that this is actually underrated, the Zener. Now I didn't have the correct or suitable rating Zeners previously, so I actually connected two 12 volts in series. Okay, and somebody pointed out, by the way, that if you use two 12 volt Zeners in series instead of a 24, and the Zeners are still 1 watt, which is the original rated one, I wanted to put a 2 watt in. If they're 1 watt, then the dissipation is still 1 watt. It's the rating of the lowest rated Zener diode. But that's not the true whole story of this. I digress. But anyway, if you have a circuit like this is basically what we have, by the way. So these are on that power supply board. These are the 200 ohm in parallel. Yeah, this is where I measured the 50 volts here. Okay, this is the 50 ohm or 51 ohm that's on the PCB, the amplifier board, and then we have the Zener diode to ground. Okay, And this is a 24 volt 1 watt. Now what I did is I put two resistors in parallel on the one I had. So I did effectively what they do there with two resistors here. And it's obvious that the current, when you put two in parallel, half flows through here and half the current flows through there. So the wattage, which is watts equals volts times current, yeah, if you halve the current, because you're sharing it between the two resistors, you halve the wattage that's dissipated by each. And that's obvious. What seemed less obvious to at least some commentators, but you know, we all have to learn this, is that if you do this, okay, this is your 50 ohm, and this is 12 volt 1 watt, and this is another 12 volt 1 watt. So the total voltage dropped across this is 24. They effectively work like they're in series, so you get 24 volts. And somebody said quite rightly, but also quite wrongly, that the maximum wattage for the circuit is the wattage of the lowest rated. So for example, this was a 5 watt and this is a 1 watt. The maximum would be 1 watt, the lower of the two. Okay, they're both 1 watt. And that is true, but where here we had two resistors in parallel, here we have two diodes in series, and half the voltage is being dropped across here, and the other half the voltage is being dropped across here. So the same applies. Each Zener has half the voltage across it now, and if the voltage is half and the current is the same, then the wattage dissipated by each one is also half. So the total wattage dissipated here is 2 watts, even though they're 1 wattage. There you go. So the person who commented about the wattage being the rating of the lowest one was correct. They just weren't taking into allowance the fact the voltage is now halved on each one. Anyway, we digressed. I've removed this board now. It's still attached to the transformer, but it's out of the way. And I can now easily get to this, and you can see for yourself where all these transistors are soldered across here, okay, to the end of the board. And I have to unsolder all of these because I need to get this board off. A previous engineer on the other two had actually cut the legs on the component, like the resistor, and just soldered one from here to here. Okay, and the same with the Zener diode. The problem with that, well, it's twofold really. One is just bad workmanship, and considering I'm charging the guy to repair this, I have no excuse not to do the job properly, even if it takes longer. I just charge him a bit more, okay? And secondly, when I looked at the other ones, which I dismantled, I found there were some bad joints generally under here anyway. So for both those reasons, I need to take the board off. As I recall, in actual fact, one of these transistors, in fact, that one doesn't look too clever. You see the joints here, this leg going in, looks bad there. This is where I had a dry joint, and that probably fixed another problem before I even diagnosed what was causing another problem. So those are the two reasons why I'm going to take this board off. And I do hope that in your repair work you will have the same opinion. But you know, comment down there, let's talk about it, yeah? This is where one of these things really pays for itself, yeah? Really pays for itself in time saved, because it's making such an easy job of this. You see the large slots I mentioned? Not sure that one completely unsoldered. I think it has now. So I'm unsoldering one transistor, just putting the cleaning rod through and doing the next one and so on. If you do this before it clogs up, it saves you quite a bit of time. I have one there that didn't unsolder cleanly. Not much of a problem. Put a bit of fresh solder on it. Okay. Go again. Much better. Okay, almost there. Okay, let's see if we got all of them. Well, we can see some of them are free and some of the legs are still attached to the board here. Yeah. I may have to use the desoldering tool again, but I might just be able to free these up. So let's just get a soldering iron. There's no solder on it. Yeah, that one moved. That one moved. That one moved. These. Yeah, that's free now. Yeah, just this one here is being a little bit troublesome. Now it's free. So that's how to do these guys. Okay. These are all free. Those are all free. Even that one's free. Yeah, this one's just not free, the last one. Always the last one, yeah. There. So that wasn't a big deal, was it? Let's have a look at the board. Okay, so here's the PCB. This is the Zener diode. That's the resistor. If we look underneath, it says 50 ohms. 1 watt 24 volt. So just dig into the solder a bit, make sure I have a good connection. That is definitely open circuit. And the Zener diode does read okay. These are the transistors where I thought I may have a bad soldered joint. Let's just have a look. Yeah, this one doesn't look too clever. And that one doesn't look too clever either. They're probably okay, but let's just resolder those as well. So the second one up and the last one. These transistors are not part of the same circuit, by the way. These are part of the actual amplifier channel. Okay, but let's just do them. This is one of the reasons why I took this off. Yeah. That one and this one. Okay. Looks quite a bit better now. Right. A few of these look a little bit dodgy. But this is not related to the actual fault that we have. So, let's take this resistor out. There it is. Really toasted, even the colours have changed on it, basically. You can see it, so it's green, red, black. So that's 5.2 and no more zeros. It's actually a 52 ohm resistor. Even though on here it actually says that it is a 50. Okay. The resistor is definitely open circuit. Okay, I don't have any exact. I was just going to try putting two resistors in series with each other to make a close value. But I found this one, which is a used one, but this is a 51 ohm resistor. This is certainly a 1 watt, probably a 2 watt resistor, so much larger. I mean, it would make sense because this resistor is 50 ohms and the two in parallel on the other board are also coming to 50 ohms, and they're probably passing the same currents, but we can't say that for certain because some of the currents will come through this resistor into this 24 volt. It's possible the 50 volts is also going to power something else. But I think I can probably put this in here. It's a much bigger one. Okay. There's quite a lot of space down here in this amplifier. It's not in the way of anything. So even if we stick it vertical like that, and then we'll just extend that wire a little bit of heat shrink to stop it shorting against anything, I think that's perfectly satisfactory. So let's put this in. But I think I should remove the rest of this as well, if it'll come off. Okay, that's not coming off totally easily, but it's nowhere near the electrical connections now, so it can't really do any harm. I'll leave it like that. I will just get rid of the bit that was inside there, of course. I also bought some of these last time I was repairing these type of amplifiers. I commented that I had no 2 watt Zener diodes, and supposedly these are 2 watt. Maybe that number will tell us, or they're marked with something. Sorry about the noise from the cafe next door, by the way, guys. So yes, ZY24, let's have a look. Yeah, the 2 watt diodes, great. That just goes to show whenever you come across something that you don't have that you need, order some. And then the next time you will have some. And while I was at it, by the way, I was searching, I also found these. So these are small outline diodes, SOD 323. We have a 1M4148 and we have Zener diodes. Okay. This only cost a few euros from AliExpress. And these ones, SOD 123, so again 1M4148 and some various Zener diodes. So I often buy things like this when I'm looking around. It may sit here for a while, may not get used, but I can guarantee the time I need it, I'll be glad I have it. And they were cheap to buy this sort of stuff, okay? So yeah, that's also another good way to go about having a good stock of parts in. So although I know this Zener diode is okay, I'm going to change it for the 2 watt because this is the third one of these that have problems in this area, and on both other occasions the diode itself had gone short. So let's do that as well. This is purely a precaution, but given the fact you have to unsolder all these transistors to get at this, then it makes a lot of sense to do it now, yeah. They have a band who come and practice at the cafe on a Thursday. I think Detlef was somewhat responsible for this, unfortunately. So, yeah. It doesn't help when you try to make videos for sure. It's not really a problem. It means I can have a bit more of a time off on a Thursday. But I need to finish this job today, so let's get this done. Okay, so that's done. Because I don't want to put all this back together and then find it still isn't working, I'm just going to apply this power from the main board of this and see if we have the 24 volt. Okay, so I've just clipped the black meter lead on there. I'm holding the red meter lead on here, okay. I just have one hand free now. So when I switch this on, I don't have any of the high voltages connected to the amplifier, just this supply for the 24 volts. Now I want to see that I get 24 volts here. So let's just switch this on and see what happens. It may go click. I remember the last time I was doing these, the relay clicked because the voltage was present and it made me jump. So I'm ready for it this time. What happens? And nothing happens, okay? Nothing happens. Oh, I see why I've forgotten to connect that one. But there's probably now some high voltage in these. In fact, I'm sure there will be some high voltage in these leads because the capacitors will have charged up. So I don't want to get messing around with this lot with the risk of shorting out one of these high voltage rails to something and doing a lot more damage. Yeah. So let's just go into volts. This is the discharger. Let's see what we have. So put the black lead in. Let's discharge these capacitors. They pretty certainly will be charged up. I'm fairly certain they will have a high voltage in them. 15, 14. Well, that's discharging actually with something. Minus 15. So I'll just discharge these. I'm not sure what was discharging them because they're not connected to anything, but hey, there must be something. When I say not connected to anything, I mean not connected to the main amplifier board. So let's just get rid of this. And then we'll do the same with the other ones. And then let's connect this lead back up that I forgot. And we'll try again, yeah. Okay, so I need to put a lower value resistor in this thing, to be quite honest. It's too slow, but it's safe. I think the ground is common. So what do we have here? Well, in actual fact, the ground isn't common, I'm thinking now. Go into here. What do we have? $65 volts. So a lot of voltage here. Okay. Same with the negative side, there'll be a lot of voltage in here. Let's see, minus 70, so we need to get rid of this. I mean, there's obviously not enough voltage now to harm me particularly, but if something touches something, it may well harm some components on the board. That's what I was more concerned about. That's why I want to get these things discharged down to something safe. Okay, let's get in there. Let's see if we can get them, yeah, getting down below 10 volts now. Okay. I'm getting less concerned by the moment. Okay, right, let's just connect this other lead, the one that I forgot. I have the lead connected now here, okay, to the amplifier, which I've moved over to this side. That's connected to the power supply now. I have a black meter lead connected via this crocodile clip lead. I'm on the Zener diode. Let's power this up, and we may well hear this click. Okay, so power it up. Yeah, it clicked 20.8 volts. So it's less than 24. It seems that that Zener is only there just to limit it if it tries to go above that. We now have a higher powered resistor, a higher powered Zener. So this should be good. I need to put it all back together now and test it, okay? Of course, not forgetting to discharge the large capacitors again. It makes sense to bolt the PCB down before you solder all of these. And then make sure that all the legs are in the slots, because if you start to solder these down and you've missed one, it's bent underneath, it's the pain in the butt. Yeah, you really don't want to go down that hole. So just check they are all in place, and these are all looking good, and now I can solder them back together. Okay, so they're all soldered back in. Just check them. A little bit of solder came down there. Can you see that on the legs? So because the slots are quite big, the solder tends to kind of run down a little bit. Yeah, I got that one. I don't think it was cause a problem. It's just how the thing is made, basically. That's just a bit of crusty stuff. I'll just get that off the board in a moment. Okay. Right. Let's see what we have then. So I'll power this up again. Blue is on. Nothing different on the lights, but we hear the relay click now, okay? So let's see if we can attach some speakers to this and give it a go. Okay, so it's powered up on the bench. I've connected the speakers. All we need to do is try this. And you know I always have some Northern Soul on, yeah? But I'm going to put something else today. This could have been Northern Soul, really. I never heard this back in the day. I found this because I was looking for some Christmas music that was so obscure that nobody claims copyright on it. Although somebody probably does own the copyright to this, but so far so good. I haven't had any problems using this on Gran Canaria Uncovered for the Christmas videos. So anyway, let's see. And I'll play you out with this one. Yeah. You got to move your feet, don't you think, to that, yeah? A few backflips and whatever, what do you think? Yeah. Okay, so this one is definitely working. And hopefully you can hear me better over the music. That's 3 out of 3, all with basically similar faults. You can see I've effectively repaired and upgraded this one. So, I think all was good. Hope you enjoyed that, and I look forward to seeing you all soon again on Worthy Let's Fix Repair. And come on, let's play out with a bit of this. Okay guys, Merry Christmas to all of you. See you soon.